Okay, so good day class. So welcome to our week 6 lecture for Building Tech 5 on alternative construction methods or modern construction methods. Okay, so today we're going to discuss about hybrid concrete construction. Okay, so hybrid concrete construction is a method of construction which integrates precast concrete and cast in situ concrete to make at best advantage of their different inherent qualities. So the accuracy, speed, and high quality finish of precast components can be combined with the economy and flexibility of cast in place concrete. Okay? Then hybrid concrete construction produces simple, buildable, and competitive structures. So the client is given better value and the contractor benefits from the increased off-site component manufacture, safe and faster construction, and consistent performance. So these are the benefits class of using hybrid concrete construction. For the cost, the structural frame of a building represents only 10% of the total construction cost. The choice for the frame has dramatic consequences for subsequent processes. Hybrid concrete construction is able to offer greater speed, quality, and overall economy on a project. So the use of concrete has additional benefits in assessing whole life cost, a factor important to occupiers and PFI operators. So for example, the thermal mass of concrete can moderate energy demands in cooling and heating buildings. The next benefit is buildability. So as precast and cast-in-place concrete are used when where most appropriate, construction becomes relatively simple and logical. So the use of hybrid concrete construction encourages design and construction decisions to be resolved at the design stage. So the use of hybrid construction also means that the percentage of the frame is manufactured by a skilled workforce in a weatherproof factory, resulting in faster construction and better quality. So the next is safety. So a high proportion of the work for a hybrid concrete construction project is carried out in the precast factory. So on site, the use of concrete construction helps ensure that each safety plan is drafted on the individual project's merits. So hybrid concrete construction can reduce the potential for accidents by providing successive work platforms on a generally less cluttered site. So the next is sustainability. So hybrid concrete construction offers the opportunity to exploit the inherent thermal mass of concrete by exposing the soffit of precast concrete slabs. So this fabric energy storage of the structure can help to control temperatures in the context of a naturally ventilated low energy building. So the finish and shape of exposed concrete units can be used to help with the even distribution of lighting and to reduce noise levels. So currently for all buildings, the operational energy consumption is far more significant than that used during construction. So, but concrete buildings using thermal mass can reduce this impact on the environment by minimizing the need for air conditioning. Okay, so these are the examples, class, of our typical hybrid construction options. Okay, so you have here the type 1, when you can see that the gray portion here, that's the precast twin wall and lattice girder slab with cast in place concrete. Okay, so the green portion here, it's I think this is the precast twin wall. Okay, and the the gray one, this is what the cast in place concrete will be. So you combine uh, both elements. Okay? So some parts are prefabricated, like here, and then the gray part here. it's already uh, cast in place. So meaning that you're going to uh, pour in the concrete at the site, just like in the conventional method of construction. Okay? Here we have the type 2. This is the precast column, and the edge beam here, it's going to be cast in place inside. Okay? It is faster because what you have to do is just connect the precasted column here, the green one, with the uh, concrete which is casted in place. Then you have here the type 3, the precast column and floor units with cast in place beams. So here class, in this technique here, the green portion here, the columns and the slab, it's already precast or prefabricated and in the factory. Then the beams, you're just going to uh, pour it during the construction in the site. We have here the type 4, and wherein these are the inside columns or walls and beams with precast floor units. So the green one class is the precast, and then this one here is cast in place. Okay. Then we have here the type 5, which is inside column and structural tapping with precast beams and floor units. So the floor units and the beams, it's already precasted. Okay? But you're going to do the columns, okay? And some of the units um, in the site. Okay? Then we have here the type 6, which features inside columns with lattice girder slabs with optional spherical void formers. So the type 6 class, this is going to be your assignment later on. Okay? So here class, in figure 2.2, you can see a type 1 construction using the twin wall erection. So this is an actual picture of the construction itself. Okay, so often the twin wall system is combined with the use of lattice girder precast soffit slabs with or without spherical void formers. So these provide permanent shuttering for an inside slab that can be relatively easily fitted to the wall system. And spans up to 8 meters are common, and spans up to 14 meters are possible. So the manufacturer should be consulted early on to ensure that the longer spans are viable. Okay? In normal construction class, especially here in the Philippines, 8 to 14 meters a span is considered already quite long. Okay? So if you're going to use the traditional method of construction here, uh, using cast in place, there are a lot. It's going to be hard to achieve an 8-meter span. Okay? I think the longest I've experienced so far is around 3 meters, 3 to 4.5, something. So it's really amazing that you can achieve 8 meters. Then the potential structural uses of the twin wall system include cellular type structures for residential use, walls carrying vertical loads only, shear and core walls. So this has significant implications for the design. Okay, so we're going to look into the section 5.1 of the book. Then retaining walls, this has significant implications for design uh, at section 5.1. So the major advantage is that it is an in-site structure. So fully continuous and tied together, but without the need for shuttering on site. So twin walls can also be cast with fully trimmed openings and with ducts for cables and other services. So the advantages, it's quality finish for walls and soffits. Then no formwork for vertical structure and horizontal structure where lattice girder slabs are used. Then structural connection between walls and slabs is by standard reinforced concrete detail and inherently robust. Then you also have reduced propping. The disadvantages are the propping of precast required prior to sufficient strength gain of inside concrete. Then the smaller dimension of the precast units is typically a maximum of 3.6 meters. So joints in walls and soffits must be dealt with, expressed, or concealed. So reduced flexibility of layout on this option requires walls rather than columns. Okay, so let's go back to type 2. Precast column and edge beam with inside floor slab. So here class, the beam and the column are prefabricated off-site. Then the floor slab, this is the one which will be cast in place. So what are its advantages and disadvantages? So the advantages are the columns can be erected quickly because it's already manufactured in a factory off-site. Then you can ensure quality finish for columns. Then the precast edge beam contains post-tensioning anchorages. If required, then the slab edge reinforcement and cladding fixings and avoids need for slab edge shuttering. Then can be used with a variety of inside slabs selected to suit individual project requirements, and it's more flexible for late changes. And then the disadvantage is that inside slab requires false work, form work, and curing time, just like a regular concrete construction. Okay, now let's review again type 3. So in type 3, we have here a precasted column and floor units, and then the beam will be the one which will be cast in place. So what are its disadvantages and advantages? Excuse me. The advantages are the vertical structure can be erected quickly, then no formwork is required. Then the precast floor structure can be erected quickly because no formwork is required. Then there's a quality of finish for columns and soffits, although this is not always possible with hollow core units. Then the structural connection between precast elements is via standard reinforced or post-tension concrete. The disadvantage is that the precast flooring must be temporarily propped, then the ceiling between precast units is required. So this is an example of a Type 3 project class at the Paternoster Square and Office Building by John Doyle Construction Limited. Okay, then this is another picture from Homer Road by Fogo Associates. Now let's go to the Type 4 construction. So let's review the picture again. So in Type 4 construction, the inside columns or walls and beams with precast floor units. So the floor units are precasted already, but the columns and beams are casted in the site. So what are its advantages and disadvantages? So the advantage for this is that the precast floor structure can be erected quickly. Then there's a quality finish for soffits, although this is not always possible with hollow core units. Then a short lead time for standard precast products. The disadvantage is that the precast flooring must be temporarily propped, and then the sealing between the precast units is required. So this is an example class of a Type 4 project in R Park, Westway, Southampton. Okay, as you can see here, the columns and beams they are casted in the site, while the floor systems here it's done off-site or in the factory. Now let's look at the Type 5. Okay, so let's review the image again. Okay, so Type 5 here, the inside column and structural topping with precast beams and floor units. So here the beams and some of the floor units are precast, while the columns and the toppings here, it's cast in place. So what are its advantages and disadvantages? Okay, so in the type 5, the advantages are that the precast floor structure can be erected quickly. The precast beam supports precast floor units, minimizing floor propping. Then the precast quality finish for soffits. Then formwork for inside columns can be used to prop precast beams. Then the structural connection between precast elements is via standard reinforced concrete. Then inside structural topping to beam permits beams to be continuous over columns. The disadvantage is that the downstand beams need to be coordinated with the services distribution. So this is an example class, the Type 5 project at a home office in London. Okay, okay, so some of the elements here, it's already manufactured off-site. Okay, so let's go to the Type 6. Not going to discuss this because this is going to be your assignment later on. So this is an example class, how you're going to do it. Okay, so I'm not going to discuss the details on the structural computations. Okay, so okay, let's move into the original. Okay, so the typical hybrid concrete options. So our lesson class is just the general overview of the typical hybrid concrete options. Okay? But this is a still a considered one of the modern methods in construction when you're going to combine cast and paste then offsite units. So what's important here, class, to remember are the 6 types and the differences between them. Okay? So I'm not going to discuss the details because it might one semester is not enough to fully master this one because you have to discuss other methods as well in construction. So what I'm going to provide you class is the general overview. Then try to read more materials and try to research more if you are interested with this modern method of construction. Okay? So I hope that when you graduate someday and in your practice as architects, you try to experience working in larger firms, large construction firms in the Philippines or abroad to be able to experience and how to do these modern methods of construction. Because these typically you can see here in the provinces. Okay? So if you have any questions or clarifications, class, please don't hesitate to contact me anytime. See you next week, and I hope that you learn a bit about uh, hybrid concrete buildings. Okay, so stay safe.